Good day, everyone. Welcome to Direct Stars. Our topic for today is electric field. Our name of today's lesson is for you to understand the concept of electric field. Today's objective is for you to know how to define electric field, electric force in a field. So in the first, what is electric field? Yeah, you know, electric field can be defined as the region around a charged particle or object where an electric force would be exerted or other charged particles or objects. So, a gravitational field exerts a force on a mass. That's gravitational field. That's gravitational pull to the earth. And this earth gravity keeps our feet on the ground. So this same phenomenon happens in magnetic field, which exerts a force object made of iron or steel. Same thing, similar way happens in electric field because it exerts force in the region of a charged object. So a charged object creates an electric field around itself. Important points about an electric field are listed below. But before going to that, so let me explain how electric field looks like. So we'll go with this. So this is the charge itself. Now this is what we call electric field. We have this, we have these here, we have these, and we also have these. Okay, so now from this side, this is what we call electric field. All these sides are called electric field. Okay, so these are electric field lines. These are the lines, while all this region, all this space are called electric field. Okay, so let me explain further. This can be shown by electric field lines. So these are called electric field lines. These are the lines here. Okay, so a charged object creates an electric field around itself. This is the charged object here. So we don't know if it is electron or proton, positive charge or negative charge. Don't worry, I will explain further. So the electric field is strongest, closest to the charged object. So this field here is the strongest. Why? Because it's close to the charged object. That's what it means here. Why? Further away from the charged object, the field is weaker. So why this region are so weak? Because they are what? Because they are in a large distance to the object itself. That's the charged object. Field lines always point away from positive charge and towards negative charge. What does that mean? That means positive charge and negative charge. This is how to differentiate positive and negative charge. Okay? Positive and negative charge. This is how to differentiate them. So in a positive charge, we have these. So field lines always point away from positive charge. Now this is positive charge. Field lines always point away. This is what we mean by point away, because it's pointing away from the positive charge, away. Okay, so these are positive charge. Okay, so this is positive charge, while negative charge is towards the charge itself, towards the charge. So if we mean like towards the charge means it's going into the charged object. It's going into the charged object. It's going into the charged object. So going into the charged object just like this. So this is negative charge particle. Why? How do we know that it's a negative charge? Because these lines are going into the charged object. So this region here is what we call electric field. Okay, so let's move on. Now showing this is the positive charge and this is the negative charge. So we go to electric force in a field. Now, what are those force in this electric field? Electric force can be defined as the force exerted on charged objects when they are placed within an electric field. So those force that are charged, exerted on this charged object, are what we call electric force. So what does that mean? That means there are some forces here. So when other charged particles is coming closer to this electric field, there are some forces here that exert on this charged object. This is what we call electric charge force. So the force is either attractive or repulsive. So we have attractive force or repulsive force. Then why are they attractive and why are they repulsive? In the first place, we need to understand that if the charge are the same, that is, this is negative to negative, then we have what we call repulsive force. How do we know if it is negative to negative? Remember, the negative charge has the lines that go into the charged particles, just like this. Okay, so this is negative charge. Now, if another charge is coming, okay, there's another charge coming that is going into here. This is what we call repulsive force. So the force here around this region, okay, the force here will repulse this charge coming into it. That means it won't allow it to connect into these charged particles. So it will send it back. It will resist these charged particles coming into it. That's what we call repulsion. That's repulsive force. While the other one is opposite charge attract. When opposite charge attract, it means if the charged particles coming into this charge, the other charged particles coming here, so this is negative charge. So if this is positive, the charged particle that is coming here is positive, then we have what we call attraction. That attraction, that is, it will attract the object closer to the electric field. Okay, so that's the difference between attractive force and repulsive force. Okay, so let me just show you this. So we have it here. So when the negative particles enter the electric field, it feels a force of attraction towards the positive charge. So the size of the force depends on the strength of the field at that point. This means that is either stronger as the distance between two charged objects decrease or weaker as the distance between two charged objects increases. So if the object, the attractive force, okay, if the object is more closer, then it has more attractive force. But if the object is further away from the charge, then it has a weaker attractive force. So that will be the end of today's class. That is the end of electric field and its own force. So thank you for watching, and please don't forget to click on the subscribe button. Bye.